In the second phase of CHIP, we will use a sonicator equipped with a microtip to shear our DNA to fragment sizes of 100 to 1,000 base pairs. The conditions for shearing must be empirically derived and optimized before proceeding to any of the following phases. Results vary depending on your equipment, cell type, cell density, cross-linking efficiency, and shearing conditions. However, there are several general tips for successful DNA shearing. First, keep the sonicator tip close to the bottom of the tube and limit the volume to 400 microliters. This will prevent foaming of the sample, as foaming decreases the efficiency of the sonication procedure. In addition, perform a time course of multiple short sonications instead of fewer longer treatments. This minimizes heat buildup and unwanted denaturing of your chromatin. For example, we find that 6 15-second pulses at 50% power output works well for us. Placing the sample back on ice to rest for at least 60 seconds between pulses will cool the sample back down. After the samples have been successfully sheared, centrifuge each at 4 degrees Celsius for 5 minutes at 12,500 G. Remove the supernatant and transfer to a new tube or aliquot into 10 40 microliter samples. These samples can be safely stored at -80 degrees Celsius for up to 1 month. To test for shearing efficiency while optimizing this phase, and optionally afterwards, run 1 aliquot of your sample on a 1.5% agarose gel. To do this, dilute the 40 microliter sample with 160 microliters of IP elution buffer and 8 microliters of 5 molar sodium chloride. All buffers are detailed in the written protocols found in the support section of the Novus website. Incubate at 95 degrees Celsius for 15 minutes. Finally, run 10 microliters of the diluted sample with loading buffer and DNA binding dye alongside a 100 base pair ladder to verify fragment size. Here is an example of DNA that has been under-sheared in lane 2, perfectly sheared in lane 3, and over-sheared in lane 4. And here is a spectral image of the same gel. Note the even distribution of fragment sizes in lane 3. You can now proceed to the immunoprecipitation phase.